batch yield and energy efficiency monitor. Copilot is built using Microsoft Plant Designer. This solution demonstrates how AI turns internal production batch data into actionable efficiency insight, helping supervisors identify inefficiency and improve operational performance. This batch yield and energy efficiency monitor follows a AI first design approach. Instead of relying on static reports, intelligence is embedded directly into the production monitoring workflow. Copilot continuously analyzes yield and energy usage to surface issue and improvement opportunities as early as possible. So the design starts with a clear definition of production performance efficiency requirement. These requirements are entered in the Microsoft Plan Designer, which generates a structured plan outlining process, components, and supervisory roles. The planner acts as the architectural backbone, ensuring AI analysis, automation, and reporting work all work together seamlessly. The user roles are production supervisor, process engineer, planner. These are the three user roles that we have. And the process that are outlined are batch data capture and normalization. This process involves defining and capturing standardizing batch data. This batch data contains about the yield, energy usage, process parameters, etc. So it captures and normalizes the data. And the next process is AI performance analysis and issue highlighting. This copilot analyzes standardized batch data to detect deviation in yield and energy consumption. It flags the inefficiency and generates explanation for supervisors and engineers. This process provides real-time insight, alert, and prioritization of batches which needs attention. The third process is trend monitoring and supervisor review. Supervisors and engineers monitor efficiency trends over time, review recurring issue, track the effectiveness of improvement action. This process supports ongoing visibility into operational performance and helps prioritization, action tracking, and continuous improvement. This is the last process. For these process, the plan design has created different tables. The data model is there. So based on these data model, it has suggested different tools, apps, etc., which we have created. And these are the apps and tools. Batch process monitoring is a model driven application. This app helps the supervisor and engineers track their live batch yield, energy usage, and trends for rapid issue, which I will show you. So this is the batch performance monitor. It has different screen. One is batches, batch performance, process parameters, efficiency trends, copilot insights, and user roles. So all of these are different screens which helps a supervisor to monitor. In the screen, you can download the data with an Excel. You can visualize it using charts. You can email everything. So the next application is Planner Control Center. I will open up that app also, which we have created. This is the Planner Control Center where we have active process parameters, action task, and then active action task, and then active user roles. Okay, these are the data that has been inputted by the technician and used for reporting and reviewing. And then we have an agent created on top of these tables, which is called as Efficiency Insight Copilot. So the data we saw on the screen where the data can be inputted can be summarized by the Copilot in case if you want to ask some question, get a quick report on it. this agent will be helpful. So here, for example, this is the test simulation of the agent. Here you can see I'm asking what are the different task action that are active. So as we saw on the previous screen, so these you would have seen this pH level, viscosity. So these are the active tasks that are available. I've asked one more thing, just for another example. I'm asking it to map the batch and the task action. So it is clearly mapped batch and the task action. So this agent sources the data model that we have created, the apps, whatever you input in the app will get loaded into the table, and that is the source for the agent. Agent always grounded with the reference data that it is referring to. So for example, here the process parameter is the table that it is referring to. Will ground it with the reference data. So this is how batch yield and energy efficiency monitoring is designed using AI first design approach and drives continuous improvement. Production becomes more efficient and predictable, not just because supervisor analyzes more data, but because Copilot and AI driven automation surfaces, it is become easier and